In this video tutorial, we are going to build this CPM diagram that you see on your screen. The user can draw new nodes with the mouse after the template. Each text in each node can be edited. Users can choose among 3 link colors. A layout algorithm is applied via a button click. The sample uses MindFusion's WPF diagram library, table nodes, and the layered layout. Let's get started. We create an empty project, which we name CPM Diagram, and choose .NET 6 as framework. We will add the diagram assemblies from NuGet. We search for MindFusion Diagramming and install the WPF package. We can look in the online documentation how to declare the diagram namespace and how to initialize a diagram. We just copy the sample code. If we've done everything correct, our application should already support some basic diagramming functionality. Let's run it and try. Yes, we can draw nodes and links. Everything seems fine. We go to the code behind file and start coding the application. If we get back to the final version, you can see we need several brushes for the nodes. We also need a designated brush for the link, which stores the currently selected color. Let's declare 2 numeric variables, the column width and the row height. If you remember, when we first ran the application, we were able to draw rectangle shapes with the mouse. Our sample uses table nodes, and we need to change the shape that is drawn by default to a table. This is done through the behavior property, which uses the behavior enumeration. The behavior enumeration has lots of members and allows you to choose how the diagram responds to user actions. The right behavior in our case is link tables, which allows the user to create and link tables. We also create a helper class, which will store the data for the table node. Each node uses 6 numeric values for the start, finish, duration, and total float properties. We also need a string property for the label. All this information is provided through the activity model class. We will now declare the method that will customize a default table, which is drawn when the user creates a new node. The default table does not look like the tables from the CPM diagram, and we have to change a few settings. We set the shape to be rectangle to avoid rounded edges for our tables. The column and row count is 3. The middle row has a call span. The connection style is table, which means tables are connected as whole objects rather than row to row. We then specify some appearance properties, the stroke, which paints the cell borders and the outline of the table, the table background, and the frame style of the cells. We center the text and add a small padding. Last, we hide the table caption by setting its height to 0. Now we add some styling to each row. The columns and rows of a table node are accessed through properties with the same name. We set the column width and row height of each column and row to the respective constant, which we declared earlier. Table node has an enumerator, which identifies cells through their column and row index. We center both horizontally and vertically the text in each cell. The text color of cells at the last row is white. Now we'll set the text and styling to individual cells. The cells on the first row use the earliest start, duration, and latest start properties of the activity model class. They are painted with the green and light blue brush. The row in the middle has a column span of 3 and renders the activity label. Its font is bold and the text is aligned in the center, both horizontally and vertically. We add now the text and styling for the cells at the last row. They use the latest start and finish properties as well as total float for the data. They are painted with 2 different blue brushes. Now, whenever we call this method, we can be sure that the table node that is passed as argument is styled the way we want and gets its data from the correct properties of the activity model that is provided alongside. We are going to declare a separate method, createTables, which we will call from initialize component. In createTables, we will create all tables from the initial diagram, together with their activity models and links. A convenient way to create a table node, indeed any kind of node or link, is to use the factory class. An instance of it is available as a property of any diagram object. We call createTable and provide the location and size of the new node. The location is of no importance because we will use an automatic layout to arrange the nodes. The size matters though. The node width is 3 times the constant column width we declared earlier, and the height is 3 times the row height we specified. Then we only need to call our updateTable method, where we provide a reference to the newly created table node and an activity model, which we initialize with the values that the first activity in our CPM diagram must have. I will simply paste now the code that creates the other nodes, because they are the same. The only difference is the values and label in their activity model. Now we will create the first diagram link, the one between node A and node C. Because we don't use the factory class, we need to add the link manually to the list with diagram links. It is time that we run the sample and see what we've done so far. Here are our nodes. They are atop of each other because they have the same bounds. Node A and node C are connected. Let's add the other connections so we can run a layout on the diagram and arrange it. I add the code for the other black links. Beside them, we also have red and gray links. We declare a red and a gray brush to use in our code. Let's check the members of the diagram link class from the online documentation. There are a lot of styling properties, some of which we will use to set the color of the link, as well as the color and size of its head. What we are doing here is basically connect the nodes the way they are in the initial diagram. We won't run the diagram yet, because all we'll see will be a mess of nodes and links. Let's arrange the graph first. We will use the layered layout in horizontal direction to place the nodes in a way that we want. The layered layout looks like the best option in our case, but the WPF diagram library has more than 20 predefined layout algorithms, and you can experiment and maybe choose a different one. And here is our diagram. It looks similar to the model, but we need to apply some more styling to the links. Let's first allow interactive edit of the table cells. The property for that is allow in-place edit. Then we create a new theme and a new style. A theme can have unlimited number of styles. Each style is registered for a given type of diagram element. A diagram can have one theme. We use our style to increase the default stroke size and head stroke size of links. We also set the size of the link head to 10. Finally, we register this style as a style for diagram link, add it to the theme, and assign the theme to the theme property of the diagram. You can see now that the links and tables look really the way they should. You can edit the text directly into the table cells. What we are left to add to the diagram are those labels in red under given nodes. By default, text goes into the middle of the diagram node, in our case, table cells. In order to place text outside the node, we need to use node labels. The node label class has been recently added to the diagram and is a very powerful way to add labels outside the node, at any edge and position. First, let's look at the node label class in the online documentation. We will use the setEdgePosition method to specify where the label goes. The edges are numerated from 0, the top edge, to 3, the left edge. They go clockwise, so the bottom edge is 2. You create a new node label by calling addLabel on the diagram item that renders the label. The method returns a reference to the newly created label, which we can customize. In our case, we just set the edge position of the label and a red brush for the text. Nodes E and H have labels as well. Let's add them. Node E has drag 5 and node H has drag 20. Of course, we must call addLabel on the correct node. Here it is. Now, if we draw a new node, the node is a table, but it has the default looks of a table node. In order to change that, we will update a newly created node with an activity model with some default data. Let's declare a method updateDefaultTable, and there we will create the default activity model and call the updateTable method, passing the node that comes as a parameter. How do we know and get access to a newly created table node? We have various events for that. We choose to use the initializeNode event. The event data provides the new node as a parameter. In the event handler, we only need to call updateDefaultTable. And now, newly created tables looks exactly like the rest of the table nodes. Good. Let's add now the table node that serves as a legend to the diagram. We add the code for it and replace the numeric data from the activity model with labels. You might remember that at the top of the final application, we had rows with labels that explain the abbreviations. Let's add them. We must edit the grid container and add 2 rows with fixed height and a third row, which takes the rest of the space and holds the diagram. These are 2 stack panels with labels, nothing special. Let's just paste them. Now let's add the button that rearranges the diagram when clicked. We need it to let users arrange the diagram once new nodes are drawn. Let's add the button now. It has a small margin and the background is old lace. We must handle the click event, where we will simply call the arrangeDiagram method. We create a few nodes. And here it is. The diagram gets rearranged in a much more presentable manner. That's great. Now let's add the radio buttons that change the color of the links, and we are ready. We add the code for the 3 radio buttons, which all use the same method to handle their checked and unchecked events. In the event handler, we look which radio button is selected and assign to link brush the respective color as presented by the radio button. Now we only need to assign this link brush to newly drawn links. We will do this in the initialize link event handler, which is raised when new links are created, just as initialize node is raised for new nodes. There we assign the stroke and head stroke of the new link to link brush. We also set the head size to be 10. We run the sample, which is now finished. We create a new node. Let's connect it with a gray brush. Here it is. Now a new node with a black brush, and one with red. Here they are. We've just finished building our critical path model interactive diagram. Thank you for watching, and thank you for your interest in MindFusion Developer Tools.